All right, we're going to review the idea of the greatest common factor, or the GCF. The greatest common factor is the greatest thing, the biggest thing, that each piece of the expression has inside it, that multiplied to be it. So if we have 18x to the third plus 6x squared minus 12x, one, we need to, in our mind, separate it that there's coefficient numbers, and then there are also variables. And we need to know what numbers and the coefficients they have in common and what variable letters they have in common. Okay? Many of you could probably just look at this and go, well, 6 goes into 6 and to 18 and to 12, and you could see that each one of them has at least one x. And so you could say, well, the greatest common factor is 6x. But maybe you can't see that. So first, find the greatest common factor of each piece. So let's look at 18x to the third. Let me shrink that down just a little bit more. Let's look at 6x squared. There we go. A little too thin. There we go. 18x to the third. There. 6x squared. And let's look at negative 12x. What do they actually break into? Well, if we look at 18, we could say that's 2 times 9. And 9's 3 times 3. So 18 is 2 times 3 times 3, if we break it down into its prime factors. X to the third means x times x times x. 6 breaks into 2 times 3. So we got 2 times 3. And then x squared is 2 x's. And negative 12, well, we can throw a negative 1 out there. And now it's just 12, and 12 is 3 times 4, and 4 is 2 times 2. So 2 times 2 times 3 times, and it has 1x. Now, if we want to know the GCF, the greatest common factor of all of those, circle the things that they all have something of. Well, they all have a 2, they all have a 3, and they all have an x. So 2 times 3 times x is 6x. That's the greatest common factor that they have. Now, if we pull all of that out, if we pull the 6x out, what's left is 3xx. So 3 times x would be 3x squared. What's left here is just an x. And what's left here is the negative 1 and the 2, so minus 2. That is factoring out the greatest common factor. Taking the thing that goes into all of the pieces and pulling it, dividing it out, undistributing it away from the piece. Okay? So if you need to, start with this. Break it down into the pieces, figure out what it has in common. But you'll start to see these better, quicker, faster. So let's look at more examples. So you have a worksheet. It's this worksheet, reteaching 9-2, okay? And we're going to use the greatest common factor to factor each polynomial. I just want you to pull the greatest common factor out. That's what it is. So what goes into 21 and 14? Well, 14 doesn't go into 21 because 14 twice would be 28. But 7 goes into both of them. And they don't both have an x, so just the 7, which leaves us with 3x minus 2. Let's see, I see a 5, a 10, and a 15. 5 goes into all of those. They all have a y. So 5 divided by 5 is 1. Y to the third, and take a y off of that makes y squared. 2 goes times 5 to make 10. Take a y off, just 1y. And 3 times 5 makes that. What should be able to happen is if you take this back in, 5y times y squared makes 5y to the third. 5y times negative 2y is negative 10y squared. 5y times 3 is 15y. It should be able to multiply back together. Redo. And go away. Okay. So number 3, they don't all have a number. Well, they all have a 1, right? But if you factor out a 1, it doesn't really change much. So I'm just going to do, they all have a letter. They all have at least one x. I pull an x off of this one, pull an x off of that one, and x divided by x just turns into 1. 3 and 6, 3 goes into both, so I can pull a 3 out of there, and they both have x, and not only do they both have x, they both have x squared. 3x squared, and I take out, and I divide it by 3x squared, that gives me 1. If I divide this by 3x squared, 6 divided by 3 is 2, and then 4 minus 2 is x squared. Let's see, we just did one like this. 6 goes into 6, 6 goes into 18, 6 goes into 24. They all have an x. 6 goes into 18 3 times. Pull an x off of there makes it x squared. 6 goes into 6 once. Pull an x off leaves me with x. 6 goes into 24 4 times. Pull an x off of 1x, and you took off the x's. They don't have a number, but they have letters in common. They have up to z squared in common. That leaves me with z minus 3. Let's see, 6 goes into all of these, and they all have at least a k. So that'd be 2k squared. 6 goes into 6 once. K squared, and take a k off makes k. And 6 into 18 3 times, and we dropped the k because we pulled it off of there. 2 goes into all of them. They all have an x. 3x squared minus 2x plus 4. If I multiply them back in, I should get the same result. Let's see, 4 goes into all of them, and they all have a p. So we've got 2p to the third plus 3p plus 1. If you take the whole thing away from it, it just is 1 left over, not 0. We're not subtracting, we're dividing. What goes into 18 goes into both of those. And if you weren't sure, you could do, okay, let's break 36 apart. Well, I know it's 6 times 6, and then I know that's 2 times 3, and that's 2 times 3. So 36 is 2 times 2 times 3 times 3. And if I needed to do 18, 2 and 9, 3 and 3. So 18 is 2 times 3 times 3. They have a 2 in common. They have a 3 and another 3. 2 times, they have 18 in common. Okay? If I need to, I can do that on scratch paper. That's fine. So 18, and they both have an x. So that's going to be 2x minus 1. 6 goes into both of these. They both have an x. So that would be just an x, because if I divide by 6x, that goes to 1. 2 of them minus 1 of them makes 1x plus, so if I go 6x, that crosses. 18 divided by 6 is 3. What goes into all these? 2 does. They all have an x. 3x squared minus 2 divided by 2, that goes there. 2 minus 1 is just an x. 2x, the x's cancel. 8 divided by 2 is 4. Give these a go, pause it, come back, look, let's see what happens. Okay, here we go. Ooh, they all got 6. Oh, and they all have x. So that's going to be, everybody divides by 6, so that's going to be 1, so that's going to be x squared plus x minus 1. They all have a 5 and an x squared. That leaves me with x plus 1. They all have a 3. No, they don't all have a letter, so it's just going to stay x squared plus 2x plus 1. They don't all have 10, but they all have 5, and they all have an x. 2x, not squared though, because I just took an x off. Silly. And plus 7. 8 goes into all of it. They all have at least x to the third. That leaves me with x squared plus 2 x and minus 1. And what goes into all of them? 6 doesn't, but 3 does, and they all have an x. So 3x squared, take an x off, minus 2x, take an x off, minus 5, take the x. And that's greatest common factoring. All right, now on the back, it tells you to simplify each project. So that means go forward. It's the opposite of what we did. Instead of undistribute, we're going to distribute. So reverse the process. 4 times a is 4a. 4 times negative 3 is negative 12. Negative 5 times x, negative 5x. Negative 5 times negative 2 is plus 10. Negative 3x squared is negative 3x to the fourth. And Negative 3x squared times 3, that's going to still be negative. 3 times 3 is 9. X squared and x makes x to the third. 2 of them and 2 of them makes 4 of them. 2 of them and 1 of them makes 3 of them. You add the exponents when the base is the same. Okay, find the greatest common factor. Back to what we did just a second ago with all those other examples. Just find the GCF. Okay, pull that out of there. Yeah. Now, find the GCF really just means what is the thing that goes into both? Well, that's 4, right? That's the GCF. But if I pull 4 out of there, I'm left with 2x minus 1. What's the GCF of number 14? Well, it'd be 15 and an x. And if I pull 15x out, that leaves me with 1 plus 3x. This one, they all have an x. So if I pull an x out, that leaves me with x plus 3. Okay. Really all it asks for is the GCF. But if you end up just factoring it all the way, that's fine, right? They say find it, and that's all they really say. So you don't actually have to do the second part. You just have to find the GCF. But if you go ahead and do it, that's what the answers would be. Factor each polynomial. Now we have to take that GCF, pull it out to the side, and leave the rest. And what goes into 8 and 10? Well, 2 does. They both don't have an x. So that's going to be, forgot the number part, 4x plus 5. Try 29 and 30 on your own. Pause it, come back. Let's see what happens. Okay, here we go. What goes into 12 and 8? Well, I know that 4 goes into both of them. And they both have an n, so that means that 3n squared minus 2. What goes into 2 and 14? 2 does. They don't both have a d, so I just pulled the 2 out. That's 7d minus 1. Remember, you're dividing these, so it's not just remove the 2 and it becomes 0. It turns into a 1. That's greatest common factor.